Hello and welcome to our webinar covering power analysis and calculation of sample size for quantitative studies. My name is David and I'll be presenting on this topic today. And just as a note, this webinar is geared towards sample size calculation for quantitative studies, and I will not be covering sample size calculations for qualitative studies. So this is for quantitative studies only. And so this is just an overview of what I will be going over today. And as a note, there will be an opportunity to ask questions at the end of the presentation. So I will ask that you save your questions until the end of the presentation. But what we'll be going over today is, first of all, talking about why sample size is important for quantitative studies. So why do we need an adequate sample size? Then we'll be talking a little bit about what statistical power is, and by extension, what a power analysis is. And then we'll talk about the basics of the most common power analysis software, which is G-Power, which is what we typically use to conduct a power analysis and compute sample size for quantitative studies. We'll go over some examples for different analyses for calculating sample size for different types of quantitative analysis. And then we'll briefly talk about sample size estimation and calculation for more advanced analyses that are not available in G-Power. And then afterwards, we'll have some open time for just some questions and answers. So first of all, why is sample size in quantitative study so important? Well, it's important because the ability to find statistically significant results from our analysis will depend on the sample size. So the greater the sample size that you have, the more likely you are to find statistically significant results, which is generally what you want in a quantitative study. Conversely, the lower sample size that you have, the less likely it is that you will find statistically significant results. Essentially, what sample size does is the bigger your sample size, the more sensitive your statistical test will be. So increasing the size of your sample will increase the sensitivity of your statistical test to any differences or possible effects or relationships that may be present in the data. The higher the sample size, the smaller and smaller effects that you are able to detect with your statistical test. And so the reason why sample size is important is if you don't have a large enough sample size, if your sample size isn't adequate, then important relationships, statistical effects, or differences between groups that you're trying to study may go undetected if your sample size is too small. So this may bring up the question, is it possible for your sample size to actually be too large? We know what the consequences are of your sample size being too small, that being, you may not find statistically significant results. But is it possible for your sample size to be too large? Well, the answer is yes, it is possible for the sample size to be too large because that comes with its own set of problems. So you can see, for example, here, if we do a study and we look at that sample size of over 380,000, and what we end up seeing when we have sample sizes that are this large is we look at our p-values, our significance levels for our tests. If your sample size is this large, practically everything is going to turn out to be significant. So you kind of have the opposite problem of a low sample size when you have a sample size that is too large, in that if your sample size is too large, then even the tiniest effects become significant, and basically everything that you test will be statistically significant. So, the result of a test being statistically significant or not kind of loses its value if your sample size is this high. And so you can think of the balance of sample size being, you can think of an analogy with a smoke detector. So obviously you want your smoke detector to be able to tell you when there's a fire, that's its job. So you want your smoke detector obviously to be sensitive enough to smoke to be able to alert you to when there is a fire present in your house. But at the same time, you don't want your smoke detector to be so sensitive that it goes off every time you're making a piece of toast. So that's kind of the balance that you have to strike with your sample size, is that you want your analysis to be just sensitive enough to detect the effects that you are looking for. You don't want it to be so sensitive that it just says everything is significant and thinks that everything is important. But at the same time, you do want it to be sensitive enough to detect the effects that you are actually trying to find. And so now let's talk about what statistical power actually is. So statistical power is the probability of finding a statistically significant effect in the sample if that effect actually exists in the population. So relating this to our smoke detector analogy, statistical power is basically the probability of our smoke detector telling us when there is a fire in the house. And power is mathematically represented by 1 minus the type 2 error rate. And if you remember from maybe statistics courses about type 1 and type 2 error rate, well, type 2 error rate is the failure to detect an effect that actually exists in the population. In other words, it's a false negative. So if in reality, or in the population that you're studying, if there actually is a difference between groups, or there is a relationship between the variables, but your study fails to show that, then that would be a false negative or a type 2 error. And so the standard for statistical power generally in the social sciences is 0.80 or 80%. So in other words, we want there to be an 80% chance, or at least an 80% chance, of finding a statistically significant effect if that effect does actually exist in the population. And so now that we know what statistical power is, it's our probability of finding a statistically significant result if it actually exists. So now what is a power analysis? Now, power analysis is a way for us to determine the sample size we need in order to obtain a certain level of power at a certain level of statistical significance with the analysis that we plan to conduct. So essentially, it's just a way for us to determine the appropriate sample size for our statistical analysis based on the level of statistical significance that we are looking for and the level of power that we want. And so in a power analysis, we calculate the sample size based on a few different parameters, and these include the type of analysis that we are conducting, the expected or hypothesized effect size. So in other words, the effect size is the size of the difference between groups, or the strength of the relationship between variables that we are hoping to find. The statistical significance level is also a part of the power analysis. So what is our cutoff for statistical significance? And generally in the social sciences, we set this to 0.05. And obviously, we need to also set the power level that we want in our power analysis. And as we talked about before, generally in the social sciences, the power that we want is 0.80 or 80%. And so doing a power analysis to determine the appropriate sample size for the study would be called an a priori power analysis. And it's called that because you generally conduct that power analysis before you do your study so that you know how many participants you need to recruit. However, it's also possible to do what's called a post hoc power analysis, where maybe you've already completed the study, so you already have your sample, you already know what your sample size is, and you want to know what your level of statistical power is. And so that is what's called a post hoc power analysis, where you kind of do the a priori power analysis in reverse and determine what your level of power is based on the actual sample size that you obtained. And that is useful when you conduct a study and maybe you didn't reach the sample size target that you were aiming for. So then you might conduct that post hoc power analysis to be able to determine what the actual power of your study was. So maybe you can discuss that as a limitation in your paper. And so there are different software packages that are already available for conducting power analysis. So, like most statistical analyses these days, this isn't something that you need to try to work out by hand. There's software available that will do this for you. And the most common software used for basic statistical analyses, at least in the social sciences, is called GPower. And so GPower is a freely available software. The website for it is listed there, or you could just Google GPower and it should come up pretty high in the search results. But this is just a free standalone program. It doesn't cost anything. It's a free download that you can use to conduct power analyses for different types of statistical analysis. And so you can just go ahead and bring up GPower here. So if you see this is what GPower looks like. And you download it and install it on your computer. You run the program. This is what the program looks like. And you can see down here, we have the different options that we select. So we would, for instance, select the type of test that we're doing, or the test family, if it's based on the T statistic or the S statistic. And then you'd select the specific type of statistical analysis that you are conducting. And there are many different options for those based on the test family. And the type of power analysis, so we talked about a priori, you can also do post hoc and other types of power analyses. And then we have options to set those different parameters that we were talking about. So the effect size, the significance level, and the power level. And depending on the type of test that you're doing, there may be other parameters that you can set as well in order to do the power calculation, but we'll be going over some examples of those in just a little bit. Another option for power analysis is actually in our the online software that we offer, which is called Intellectus Statistics. So if you subscribe to Intellectus Statistics, we actually have a section for power analysis that provides some templates based on GPower for calculating sample sizes for some basic analyses. And I'll show you some examples of what that would look like in Intellectus Statistics as well. So that's just another option for you. If GPower seems a little bit too intimidating and you're subscribed to the Intellectus Statistics software, this is an easy way for you to get some basic sample size calculations. All right, so now let's get into some actual examples for how to do these power analyses. So let's start with something easy like some basic t-tests. So I'm gonna open up G-Power here, and when we open up G-Power, if we wanna do t-tests, the first thing that we want to do is go into the test family and make sure that we are looking at the appropriate test statistic, and that would be t-tests. And then for the actual statistical test that we want to conduct, we would want to select the specific type of t-test that we are conducting. So let's start with just doing an independent samples t-test. So let's say we're comparing two groups on some variable, like for instance, comparing males versus females on some variable. And so to do an independent samples t-test, or the power analysis for that rather, we would select means difference between two independent means or two groups. That would be the independent samples t-test. And so when we select that, it'll tell us what parameters we need to input in order to conduct our power analysis. The first thing we need to select is the number of tails on the t-test, and generally you want to set this at 2. The discussion of two-tailed versus one-tailed could be a presentation in and of itself, but basically, if you think that the difference between groups could fall in either direction, you want to do a two-tailed test, and generally that's what you would want to do. And then we have our input for effect size, and generally in G-Power, it will by default have a medium effect size put in here, and for some analyses you could actually even hover over this box and it will show you the different cutoffs as suggested in the literature for different effect sizes. And generally, if you do not have a specific hypothesis or expectation as to what the effect size for your study might be, based on the literature, you usually want to go with a medium effect size. And in this case, for the t-test, the effect size that it is using is Cohen's d. And so we're saying here that a Cohen's d of 0.5 is considered a medium effect size. And then you'd enter in your, this is the alpha error probability, which is the significance level. And again, in the social sciences, we generally set this to 0.05, and that is the default in G-Power. And then for our level of power, we would set that to whatever we want our power level to be. And again, this is the probability of finding that significant result if it actually exists in the population. And the default in G-Power is actually 0.95. However, in the social sciences, generally we use a power of 0.80. So we're actually going to go ahead and change this from 0.95 to 0.80. And then we have this allocation ratio, which you generally don't need to change when you're doing the power analysis for a t-test, except if you expect your group sizes to be very different. So an allocation ratio of 1 would just mean that you're expecting your group sizes, in your t-test to be roughly equal to each other. So for comparing males and females, for instance, we would expect males and females to be in our sample in roughly equal numbers. However, if you're expecting a very uneven sample size between your groups, then you can play around with this allocation ratio and see how that affects the results of your power analysis if you have very unequal or imbalanced group sizes. And so now that we set all of the parameters for our power analysis, we can just click this calculate button and we can see it gives us the results in this output section here. And the main thing that we have to look at is the total sample size, which for our t-test is 128 using these parameters. So this means that for our independent samples t-test, in order to find an effect size with a Cohen's d of at least 0.05, have it be statistically significant at the 0.05 level, and have a power level of 0.80, we need a sample size of at least 128. So that's how we would do that calculation for the independent samples t-test. And if you wanted to do a different type of t-test, so let's say we wanted to do a paired samples t-test, you would just change the specific statistical test, and we can change that to, instead of the independent, the difference between two dependent means or matched pairs. And then we can change our settings again to make it two-tailed. We can do a medium effect size, a significance level of 0.05, and a power of 0.80. And we can calculate that, and we can see that for a paired samples t-test, we only need a sample size of 34. And so that's what the t-tests look like in G-Power. So now I'll quickly show you what it looks like in the Intellectus statistics software. So in Intellectus statistics, if you subscribe to the software, you'll see under our different options here, we have an option for power analysis. So you'd click into power analysis, and then you'd see the different tests that we have power analysis available for. And if we wanted to do the power analysis for t-tests, we'd click into our t-tests. And then, for example, we can click into our independent samples t-test. And it'll give us a write-up explaining the sample size calculation for different levels of effect size. And we see that for our medium effect size, we see that it's the same as it was in G-Power, using the same parameters that we used in G-Power, with the significance level of 0.05, the power level of 0.80, and our Cohen's d effect size of 0.5. We see that we get that same sample size estimate for 128. And that's just an example of how you can use the Intellectus statistics software to get some basic sample size calculations. So now let's try some other examples for some other types of tests that we might want to do. So what if we wanted to do an analysis of variance? Well, we can go over into G-Power, and under our test family, if we know that the analysis of variance is based on the F-test, we'd want to select the F-tests for our test family. And then under our statistical test, it gives us a whole lot of options for the different types of F-tests or statistical analyses that we could do that is in this family. And if we just want to do a regular one-way Anova, so we're comparing just 3 or more groups on a certain variable, we would select this option here for the Anova fixed effects omnibus one-way. And again, it gives us our different input parameters, the effect size, which again, it will tell you the different cutoffs for small, medium, and large. And by default, G-Power sets this to the medium effect size. Our alpha level, our power level, which again, we can set to 0.80. And then the number of groups. So the number of groups are the number of different groups that you're comparing. So if you were comparing, for instance, 3 groups, you'd set this to 3. If it was more than that, you'd set that to however many different groups you are comparing. So we see if we do this calculation for 3 groups, our total sample size turns out to be 159. And then you can play around with these settings to see how changing different parameters will affect the analysis. So what if instead of comparing 3 groups, we wanted to compare 5 different groups on a variable? We can change this to 5, and we can see that that increases our sample size to 200. So having more groups to compare will increase our sample size requirement. And what if we wanted to change some of these other settings? So for instance, what if we were expecting a large effect size instead of a medium effect size? So what if we're interested in the effect size being really, really big? So we can look at the recommended effect sizes here, and we see that 0.40 is the recommendation for a large effect size. So what happens when we set the effect size to 0.40? We see our sample size requirement actually goes down. So the larger effect size that we're trying to see, the lower the sample size required. And then what if we wanted to, I'll just go ahead and set that back to the medium effect size. What if we wanted to change our significance level? So what if we didn't want to use a cutoff of 0.05 and instead want to use some other cutoff? Like for instance, maybe we're doing a bunch of different analyses and we need to do some kind of correction, like a Bonferroni correction to our alpha level across our multiple analyses. So what if we wanted our significance cutoff to be 0.01 instead of 0.05? We can calculate that, and we can see that that'll actually increase our sample size. So making your cutoff for statistical significance more strict will increase the required sample size that you need. And then finally, if you want to use a different level of power, so for instance, if you wanted there to be greater than an 80% chance of finding statistical significance, say if we wanted to bump that back up to the default that G-Power sets to 0.95, we can calculate that, and we can see that will also increase our sample size. So if you want your analysis to have more statistical power, that will require more participants. And so that's how you can do some power calculations for basic analysis of variance. And now let's finally take a look at our last example, which is regression. So if, let's say we wanted to do a multiple linear regression, how many participants do we need for that kind of analysis? Well, we'll go back into G-Power, and for multiple regression, the test family will actually be within the F-test family. And our specific statistical test, we can look at the list here, and we can see a couple different options for multiple regression. And generally, what we pick for multiple regression is this first option, the fixed model R-squared deviation from 0. And what this is specifically testing is to see how many participants we need, or what our sample size needs to be in order for our overall regression model to be significant. Or in other words, for our R-squared to be significantly different from 0. So let's see what parameters we need to input for our multiple regression for this power calculation. We see that we have our effect size, and again, it gives us cutoffs for small, medium, and large. By default, it sets it to the medium effect size. Our statistical significance level, which we'll keep at 0.05. Our power level, which again, we'll set to 0.80. And then the number of predictors. So this is the number of predictors or variables that you have in your regression model. So for instance, if you just have 3 predictors in your regression, you would just put 3 in here. And then we can calculate that, and we see that our total sample size target would be 77. So if you're running a multiple linear regression with 3 predictors, you would want at least 77 participants for that analysis. And then if we increase the number of predictors, so let's say we have a lot of different predictors in our study, say we have 10 predictors, we can calculate that, and we can see our sample size will go up. So the more predictors you have in your regression, the larger the sample size requirement will be. And that's how you would do a basic calculation for a multiple regression analysis. And so the last thing I'll talk about before I open it up to questions is more advanced analyses. So, G-Power covers a lot of the basic statistical analyses that you would want to do for a study in the social sciences. But what if you're doing a more complex analysis that is not available in G-Power? So for instance, things like factor analysis or structural equation modeling are not options or analyses that G-Power currently is able to do sample size calculations for. So if you're doing that type of analysis, then what do you do if you can't use G-Power? Well, there are some options available, and there's no real universally accepted method for determining the sample size for these more advanced types of analyses. But one thing people will often do is look at rules of thumb for sample size estimation based on the literature for that particular analysis. So for instance, if you look in the literature surrounding structural equation modeling or factor analysis, a lot of those articles will recommend doing the sample size estimation based on the number of variables that you have in your factor analysis or in your structural equation model. So for instance, it might recommend that you have 10 participants for every observed variable that you have, or 20 participants for every observed variable. Or it might be based on the number of parameters that you have in your model if you're doing a structural equation model. So you'd have to kind of dig into the literature and see what statistics scholars recommend in terms of how many participants you need based on how complex your model is and how many variables you have in your model. Another option, and this is maybe becoming more popular, but it's a lot more complicated than just using the rules of thumb, is doing something like a simulation study, or this will sometimes be called a Monte Carlo simulation study, where you actually use computer software to generate random sets of data and run simulations of your model to see exactly what sample size you need to reach a certain level of power. And these types of simulation studies are pretty complicated to perform. They kind of require a high level of knowledge with very specific software packages, which is why a lot of people will use the rules of thumb instead. But those are just some options available if you're doing some type of analysis that is not available in the G-Power options. All right, and so that just about does it for the presentation. And just as a reminder, if you liked what you saw in this presentation, or you feel like you need additional help with this topic or with something else related to your statistical analysis, we do offer help in those areas. So what you can do is you can go to the website listed there to schedule a consultation to discuss your research, what you need help with, and we can let you know what types of services we offer to help in those areas. And with that, I will open it up to questions. I see that there have been some questions posted already, so let me go ahead and open those. What I'll do is I'll actually go back and go through the G-Power examples so that you can see those. All right, so this is what G-Power looks like. And I do apologize for the screen share not being on, but so here is G-Power. And so we can see here below, we have our different options for the test family, the type of statistical test that we can run, and the type of power analysis and the different inputs that we have. And so if we want to do this for a basic t-test under test family, we would select t-test, and then we would select the type of t-test that we want to do. So we'd select the difference between independent means. And then we would do our input parameters like we talked about. So the number of tails, the effect size, and we can see that when we hover over this in G-Power, it shows us the small, medium, and large effect size, the alpha error probability, which is our statistical significance level. So, and generally we'd set this to 0.05, and then our power level, which we want to set to 0.80. And then when you set all those, you can click calculate down here, and then that will give you your sample size calculation. And we see that it gives us that sample size calculation of 128. And that's an example of how to do that for the t-test. And then if we want to show this in Intellectus statistics, again, if we go ahead and refresh our page here, in the Intellectus statistics software that we have, if you subscribe to this software, we have options for power analysis. And if you go under the power analysis options, we see that we have a couple of different tests that are available for us to select from. And we can select into t-tests and do the independent samples t-test. And we see that it gives us output for the power calculation for the independent samples t-test for different effect sizes. And specifically for the medium effect size, it shows us the same thing that we saw in G-Power with a sample size calculation of 128. And so that's what that looks like in the Intellectus statistics software. And I could go through some of those other examples again. So we did a t-test. What if we wanted to do an analysis of variance? So for an analysis of variance or an Anova, we would select the f-test for our test family. And then under the specific statistical test, we would select for a one-way Anova, just the fixed effects omnibus one-way. And then we would define our different parameters. So the effect size, again, in G-Power, it automatically puts in the medium effect size by default, our statistical significance level, our power level, which we can change to 0.80, and then the number of groups that we're comparing. So if we're in our Anova comparing, say for instance, 3 different groups, we can change this to 3 and calculate our sample size requirement, which here it tells us that for Anova comparing 3 groups, we want 159 participants. If we want to increase the number of groups, so if we want to compare 5 groups instead of 3, can calculate that, and that tells us that we need 200 participants. So we see that we need a higher sample size if we have a larger number of groups that we're comparing. And if we want to change the other types of parameters, we can see how that affects our sample size. So again, if we want to, say, detect a larger effect size, So we expect our effect size, our differences between groups, to be larger. Can change this to the cutoff for a large effect size and see that that reduces our sample size requirement. So the larger the effect, the less of a sample size or lower sample size that you need. If we want to change our statistical significance level, could change that. So for instance, if we wanted a more strict statistical significance level, say 0.01 instead of 0.05, that will increase our sample size requirement. And then if we want to change the power level, for instance, if we, instead of a power level of 0.80 or 80%, we wanted that to be higher. So if we set that at 95%, for instance, that will also increase our sample size requirement. And so that's how you would do that power calculation for the Anova. And then finally, for the regression is still in the F-test family. And then we have the options down here for linear regression. And generally, we'd select the fixed model R-squared deviation from 0. And we would just input our parameters like before, our effect size. By default, it's set to medium, our significance level, our power level, and then the number of predictors. So that's the number of variables that you have in your regression. So, if you had 10 predictors or 10 variables, you'd see our total sample size requirement for that is 118. If you had fewer predictors, like let's say if we only had 3 predictors in our regression, that reduces our sample size to 77. So you see that as the number of predictors in our regression goes up, our sample size requirement goes up. And those are just some examples of the different calculations that you can do in G-Power. And just to answer some of the other questions, the recording of the webinar will be available later, and I believe the PowerPoint should also be posted on the website, so you should have access to the actual a copy of the PowerPoint presentation as well. And I do apologize that you weren't able to see the screen share for that part of the PowerPoint presentation, but the actual PowerPoint slides will be available as well. So did anybody have any other questions? If you do have any other questions, you may type those into the question section now. Okay, so the question is, the types of analysis that we do, multiple regression and others, should be the same that we are going to use in the specific analysis after. So yes, you want to do the power calculation for the analysis that you plan to conduct for your study. So you would need to know, in order to calculate the sample size, you would need to know what specific analysis you're going to be doing in order to analyze your data. So you'd need to decide, before you can do the analysis, or before you can do the power analysis, you'd need to decide what actual statistical analysis you're going to be using. So whether that's like a t-test or an Anova or a multiple regression or something else like a correlation, you would need to determine that and then use the appropriate type of power analysis in G-Power to make the sample size determination. Okay, so can you show how we calculate the power analysis after considering we did not get the sample size we wanted? Right. Yes, so that would be that post hoc power analysis. So in G-Power, if you want to do the post hoc version to determine the power of your study, given the sample size that you obtained, under the type of power analysis, you can see that by default, it's set to the a priori, which is to compute the sample size. We would change this to post hoc, which is compute the achieved power given the sample size that we obtained. And so when we change this to post hoc, we can see that some of these parameters stay the same, but instead of inputting the level of power that we want, instead we're entering the actual sample size that we obtained. So, and this would be, in this instance, for our multiple regression, let's say we want to do a multiple regression with 3 predictors. We know that we just calculated before that we need 77 people in order to get a power of 0.80. But let's say we fell short of that 77 sample size target. What if we only got 50 participants, for instance? So we would set our sample size to 50. We would want to keep our significance level and our effect size the same, so that we can get an accurate assessment of what our power level would be under those same conditions. But we just change the total sample size that we actually obtained in the study. And so then we can calculate that. And then it'll show us down here, this very last value here, the power level. So this will show us the actual level of statistical power that we would have for this regression analysis if our sample size was 50. And so it's showing us here that our power level would be approximately 0.58 or 58%. And you can do the same thing for any other type of analysis. So if we want to do this for a t-test, for instance, we could go back to our t-tests, and we want to do it for an independent samples t-test. Our parameters would basically stay the same, except this time it'll ask for the sample size for the 2 groups that we're comparing. So for instance, maybe to get a sample size of 128, which is the recommended if we did the a priori sample size calculation, that would be 64 people in each group approximately. But what if we fell short of that? What if we only had 25 people in each group? So we'd set our group sample sizes to 25, and then we can calculate that. And we'd see that if our total sample size was 50 participants with 25 people in each group, then the power of our independent samples t-test would be 0.41 or 41%. Right, so any other questions? So the question is, can we determine sample size based on previous prevalences or pilot studies rather than depend only on the alpha and beta values? The answer to this is yes. So especially if, like we saw before with advanced analyses, and I can pull up that slide real quick. So for advanced analyses, if there's not a straightforward power calculation for it, or if you're in a specific field where kind of the standard for sample size is based on previous studies, that is another thing that you can look to in order to determine an appropriate sample size for your study. So you could look at a previous study in your topic area that did an analysis similar to what you're doing and see what kind of sample size they had to give you an idea of how many people you need. However, this isn't the most precise way to calculate sample size, and depending on the requirements of your paper or your school or your reviewers, they might want to see a more precise sample size calculation that is actually based on significance level and statistical power. So the answer to that is you can use previous studies to determine it, but that might not always be the best option depending on what your requirements would be. So how do you enter those values into G-Power to get the sample size? So what you could do is, and maybe you're referring to effect sizes in previous studies. So we can go to an example here. So let's say you have a previous study that did a t-test and they got a certain effect size, and you are expecting in your study your effect size to be similar to that study, and you want to know how many participants you need. So what you can do is we can go into our t-tests, our type of power analysis. We set this back to a priori so that we're computing sample size. And so we have our different parameters here, and we can look at effect size and see, okay, what effect size are we expecting based on the previous study? And here, all you need to do is enter in what the effect size was in the previous study. So if it was something different than just the default medium effect size, so for instance, maybe the previous study had a Cohen's d of 0.7. So if that was the case, you would just enter in the effect size from the previous study in that parameter input box, and then calculate the power analysis based on that effect size. So if we think our effect size would be 0.7, we can calculate that and see what our total sample size requirement would be with that level of effect size. And we can see that as our effect size increases, our sample size requirement goes down. So that would be a way that you can use a previous study to inform your power calculation. Is if a previous study had a certain effect size, you could use that as your expected effect size instead of just using the default small, medium, or large effect size that's suggested in G-Power. Okay, so is there any other questions that anybody had? So if there are no more questions, again, thank you all for attending the presentation. And again, if you are interested in additional assistance, whether it be for sample size calculation or anything else related to your analysis, or just dissertation assistance in general, that is what we provide. And you can see the link here to schedule a consultation to talk about your needs, and you can get some more information about what kind of services that we offer.